Hi everyone, I hope you guys are doing well. So today we will be understanding what MCP is, what MCP stands for, and what MCP can provide us. So MCP stands for Model Context Protocol, and it was developed by Anthropic back in November 2024. And we will be deep diving in MCP clients, server, tools, and how MCP architecture works. So MCP is basically an open standard developed by AI Anthropic to enable easy and standardized integration between AI models and external tools. So this helps the developers to connect different tools with the MCP server and with the MCP client. So it basically acts as a universal connector, allowing LLM large language models to interact dynamically with the APIs, databases, tools, and many business application tools like CRM and other tools available. So let's get started with the client side. So MCP has a client. So MCP clients are incorporated by host applications to communicate with particular MCP server. So in order to understand what MCP client is, it's an host application like Cloud AI or an IDE that manages the overall user experience and coordinates multiple clients with multiple servers. So each client handles one direct communication with one server. So client is connected with the server and the server is connected with the client. So in this way, the client communicates with the server and the server sends back the specific information that the client has requested for. So MCP consists of a client and a server. We have covered what a client is. So a client can also be a cloud desktop, your IDE, or a large language model that is requesting a specific information from a server. Then we have an MCP server that are usually different programs that exposes specific capabilities to AI applications through standardized protocol interfaces. For example, we have MCP server A, B, C, and every server is connected to different tools like databases, local file storage, remote databases, and external APIs and apps. So these servers are specifically made to connect with those AI applications or tools through standardized protocol interfaces. So common examples includes like file system for accessing document files, database servers for data queries, and GitHub servers for code management, Slack servers for team communication, and calendar servers for scheduling. And this server architecture is a two-way client server architecture which interacts with the client through MCP, a protocol, a communicative way, what the client is asking about and what to respond back to the MCP client. So MCP client can be used by any app, by any large language model that supports like Cloud Desktop, Cursor IDE, Z014, etc. So this server is basically acting as a program that exposes specific capabilities of AI applications through a standard protocol interfaces with different tools. Then we have a concept of tools in MCP. So tools enable AI models to perform actions. Each tool defines a specific operation with typed input and output. So the model requests tool execution based on a context. So for example, you have a tool of, you have defined an MCP tool of search flights, and the description for that tool is to search for available flights. So this is a basic example of a tool to have a schema defined that LLM can invoke. So MCP uses JSON schema for validation and each tool performs a single operation with clearly defined inputs and outputs. Then we have a more detailed architecture of MCP, and this basically diagrams illustrates how the MCP client server architecture works. So this architecture enables AI system or any developer tools to communicate seamlessly with different data sources and services, both locally and online. So at the center, we have some MCP server A, MCP server B, and MCP server C, and we have some host client. And this host client is communicating directly using the MCP protocol with the MCP server, and all different MCP servers are connected with some different uh, tools like databases, different frameworks, and available different AI tools you can connect with the MCP server. So the MCP client acts as a central hub that initiates communication, and it uses this MCP protocol to talk to different MCP servers. Example, you can take like Cloud AI, VS Code, extensions, or custom automation tools. So these custom automation tools uses MCP protocol to talk and communicate with the MCP servers. Then we have the MCP server. Each server handles different request, different service connections, and specific data to give to the MCP host client. And MCP server A, B connects to a local, for example, MCP server A is connected to a local data resource A and B. And this could be your local files, databases, or on premise systems. And the MCP server B is also connected with some local data source B. Then we have the MCP server C, which connects to a remote services through web APIs, allowing cloud applications or internet-based integrations. Also, we can use web hooks and web sockets in this MCP server. So this whole architecture works as a client server architecture, a basic client server architecture, and the MCP client request for some specific tool through an MCP protocol, and the MCP protocol communicates with the MCP server. Then the MCP server calls the specific tool, which based on the user input query. For example, we have a large language model. I am using Llama 3.2, Quen, or any local Llama model, and I pass a user input query. Tell me about the weather in Islamabad. Or for example, if I have connected my large language model through an MCP server with a tool I have defined, that tool is connected with my local data source. I can tell me the specific information about Isaac, and that specific information is going to be called through the MCP protocol, and MCP protocol will communicate and initiate a session with the MCP server, and MCP server will talk to the specific tool, for example, to get data from a database, and my user input query will pass through the MCP protocol, and in this way, a specific answer will be fetched back from the database. So this framework helps AI tools, developers, and different software engineers to manage both local and remote data securely and uniformly. So think of it as a universal connector between your AI assistant and your data ecosystem, whether it's stored on your computer, cloud, or on the web. So then we have a question, why to use MCP? So MCP is a standardized AI integration that provides a structured way to connect AI models with tools. And it's also flexible. It allows easy switching between different AI models and vendors. Security, it's also much secured than open source large language models. Uh, you can expose your internal or remote databases with the MCP server if you have your own MCP server. then you can connect that MCP server with your databases, tools, and it's much secured within your infrastructure while interacting with the AI. Also, if we talk about the scalability, it's easy to scale up and scale down. And MCP supports various transports, like which I've mentioned, WebSockets, HTTP, SSC, and Unix sockets. So MCP helps us in many ways, and thanks to Anthropic, which they have developed this particular architecture to enable software engineers, AI engineers to make their own MCP servers and connect those MCP servers with different external and internal AI tools. So that's what MCP is about. And let's understand how we can make our own MCP server and our different AI tools to connect our MCP server and client with those internal and external tools. Thank